I know you were waiting, Zach, till I finished roll, right? That was gonna be your excuse this time?
Nice.
Man, I had to reteach myself some stuff today. I'll go over that with you, so you'll know too.
You have fun trying to teach Patrick how to submit all those tests.
Got it done. Got it done. He got it. I mean, I was flailing as well, but then he found it. I went back to it and then I remembered where it was, and then he had already found it. So that's good. Okay. Videoing. Videoing, really. That was a lot of fun. Saturday was fun for me. Okay, so anybody else come in? Did Adair, let's see you come in. Adair, Miguel, Adair. That's it, just Miguel and Adair. I marked Austin here because I know he's going to roll in. Okay, so let's go immediately to our safety meetings. To our safety meeting. Oh, just get away. Why is this on? Oh, okay. Here we are, week 10. We haven't done SDS sheets, have we?
Safety data sheets? No.
Good. And they used to be called MSDS. Who knows what MSDS means? These manufacturer safety data sheets. Now they're just called safety data sheets. And it's kind of semi-obscure as they are. They're pretty important. Pretty important when you're working with things that are hazardous and can be hazardous to get on you or breathe, inhale, God forbid, or get on your skin. You know, it can be transdermal. You can get bad chemicals through your skin. All right, I'll read the beginning. So what is a safety data sheet? What is a safety data sheet, SDS? A safety data sheet is a document that contains information on the chemical state, chemical makeup, use, storage, handling, emergency procedures, and potential health effects related to a hazardous material. The SDS contains much more information about the material than the label on the container. SDSs are prepared and written by the manufacturer of the material. John, would you please read that? What's the purpose?
What is the purpose of an SDS? The purpose of an SDS is to inform you of the material chemical makeup, the material physical properties or fast-acting health effects that make it dangerous to handle, the level of protective gear you need to wear to work safely with the material, the first aid treatment to be provided when someone is exposed to the material, the pre-planning needed for safely handling spills, fires, and day-to-day operations, and how to respond to accidents.
Matthew Awinaga, can you read the next one? What information is on the SDS?
I'm currently driving right now and I'm on my laptop.
Okay, that's cool. That's cool. Just
Yeah.
you can just listen and hopefully get pulled over at some point, right?
So,
So you can look at stuff.
I'm in the same situation, Rod. This is Eric Mendez.
Say it again now.
I'm in the same situation. I'm driving right now too.
Okay, okay. How about you, Michael? Can you read? Yeah, don't read and drive. I got you. Right. Austin.
What information is on SDS? There are 9 categories of information that must be present on an SDS. These are chemical identity, health hazard data, manufactured information, precautions for safe handling and use, hazardous ingredients, exposure controls / personal protection, physical and chemical properties, fire and explosion hazard data.
Okay, so how many of those do you guys count? How many bullet points do you guys count?
8.
Yeah, so what are the 9 categories? I hate stuff like that. Okay, so reactivity data. Who wants to read that? D'Angelo, would you read that, please?
Reactivity data. Even with all of the above information on an SDS, it might not have everything you need to know about the material. For example, health hazards information is usually presented in general terms. Your health and safety specialist should be able to help you find more information if it's needed.
Mitch, Dylan,
And SDS and to
hard. Why is it hard to read?
hard to read. Originally, SDS were instead to be used by
Wait, right. We're intended,
to be used by like
help him, somebody,
industrial
hygienists,
Genesis as chemicals and
Engineers.
engineers and safety prevention
professionals,
professionals, how SDS are used by employees, employers, in
employees, employers, emergency responders,
and any other else requiring information on a
material.
material. Some SDS look very different from others. This is because law
Specified.
specifies how
Content.
content of the SDS, but the information is left up to the manufacturer of the material.
The format is left up to the manufacturer of the material. So how he formats the information, how he presents the information on the SDS is up to the manufacturer. That's why they look a little bit different. So, John, did you read already?
You want me to continue?
How about Austin?
When would I use an SDS? You should always know the hazards of a material before you start using it. For most people who work with a material, there are sections of the SDS that are more important than others. You should always read the name of the material, know the hazards, understand the safe handling and storage requirements, and understand what to do in an emergency.
Ben?
Hazard communication standard. SDSs form the cornerstone of these standards. The hazard communication standard requires employers to maintain an inventory of hazardous materials, provide employees training on the potential hazards associated with a material, obtain and maintain SDSs for each material on site, establish proper methods and types of labels, and inform contractors of the hazards that their employees may be exposed to in their work area.
Yeah, and more information for more detailed information, discuss your questions with safety and health representative or visit the website maintained by OSHA. So hit those lights, man. And there come the lights. Wow. Lightning flash. Hey, SDS seats are pretty important. And the reason why they're important is because at some point in your career in construction, it's very likely that you will be asked to or directed to work with something that's going to be harmful to your health if you don't, if you're not careful, like acetone, methylethyl ketone, paint thinners, anything that's used to finish, even water-based materials, zinc chromates, things that are used to coat things, anything that has chemicals in it that are potentially harmful in any way to the human being, you need to, have immediate and total access to SDSs as an employee. That's provided by your employer. So if you saying hands you a thing of green stuff like zinc copernate, and he says here, and here's a throwaway brush, and here's a paper thing, go take this and slop it on these pier posts underneath this deck. Okay, smells really bad. It's just, you just say, do you have an SDS on it? You know, it's, you know, you never want to antagonize the people that are above you, especially your boss or people that are telling you what to do. But by the same token, please don't do anything that's going to cause you any harm. And it's a simple ask. I'd like to see the MSDS, because the manufacturer or the safety data sheet will tell you what's really bad in it, how bad it is, all the research done on it, how bad it is, and what can possibly happen to you, and what you can do about it. If you get exposed, if you know, it'll tell you whether you need to wear a particle mask or a actual respirator. It'll tell you if you get it on your skin, what to do. If you get any in your eyes, what to do. If you breathe, you know, it'll tell you all that stuff. And just do yourself a favor. And it's part of working safe. Know the material that you're working with, and look at the safety data sheet and look at the stuff that's important, like the PPE. What should you be wearing to protect yourself? Because it'd be a bummer to find out later, yeah, we were spraying this, you know, like in our shop, one of the things that we do is plastic laminates. There's a high pressure plastic laminates. Formica is one, right? And Formica goes down with contact cement. And by the way, here's one for the record books. One of the questions that I love to ask, and one of the questions that's on the test that I give potential employees is, what's the clamp time of contact cement? Am I recording? Yeah. What's the clamp time of contact cement?
Time?
Yeah.
Can we guess?
Yeah, please.
I would say 8 hours.
Okay, so Ben's guess is 8 hours. Anybody?
5 minutes.
An hour.
5 minutes.
5 minutes. Anybody else?
24 hours.
24 hours. Anybody else? Anybody from the peanut gallery? You might Zoom people? No? Nobody's gonna jump in there?
The volume might be down.
Okay, so check it out. Glue, wood glue, tight bond, right? Aliphatic resins, yellow glue, 20 minutes clamp time. Now you might guess a half hour, you might guess an hour. It's actually 20 minutes clamp time is what it is. I rarely break them down at 20 minutes. Contact cement, on the other hand, is on contact. There is no clamp time for contact cement. It's 0. It's contact cement on this surface, contact cement on this surface. Surfaces go together when they're tack free. So you spray it on the Formica. Nice, we sprayed it and spray it with a solvent base, not water base. Use the solvent based stuff because it goes off way better. It's way stronger, but the fumes are horrible. You want to know about the SDS for contact cement, which is bad enough, and then the spray version, because you're releasing much more in the air, not just the vapors, right? Spray it on even thin coat over the backside of the plastic laminate, the phenolic back, onto your substrate, the 3/4 or 5/8 particle board or plywood or whatever. And when it's tack free, that is when you can take a piece of tissue paper and touch it to either surface and it doesn't leave any paper, it's tack free, it doesn't stick at all, then you've got X amount of working time depending upon the temperature. Then you lay it on the material, usually lay it on dowels, pull the dowels off, and then hit it with a roller. Because the minute that material that's got contact cement on it hits the other material, the substrate that's got contact cement on it, it's a contact bond. And I'm talking about a contact bond that when you push that thing down, you're not moving it. It's not, you can't adjust it. You can't slide it around, you can't go this way or that. That's why when we do plastic laminate, your sheets are always bigger than the material because you flush trim. You don't try to line stuff up. It's virtually impossible. It's not impossible, but it's no fun. So contact cement and working with plastic laminates, stuff like that. MSDSs, SDSs are really important things to know what you're dealing with, right? So you don't you go on like, I can remember spraying that stuff and getting the worst headaches until I figured out we should have like fans going, and that's another trouble. That's another problem. And when you're spraying something like that, you want fans going. You want to really move the air, right? You want to move those vapors out and away. The problem with that in a woodworking shop is dust, because that air, those fans are gonna move particles of dust, physical particles, and that's the last thing you want on your drying contact cement. It's dust. So there's a lot of stuff to consider, but really I'm asking you to please consider, and everything that you do is consider your safety of yourself. And not just the stuff that you can see, but inside your lungs and your esophagus and your nasal passages and stuff like that. Or all that really, really bad stuff can happen and you're not as aware of it. It's like when you push your finger through a saw.
You know why we can't buy denatured alcohol in California anymore?
Do I know why?
Yeah.
Are you gonna tell me why? I'm sure they think it's bad, like, you know, that you can't buy anything over a quart of oil-based paint either, or solvent-based anything. Really, you can buy solvents, but you can still buy oil-based paint. You can't buy over a quart of it because of well, mostly because of the VOCs. So I don't know about the VOC of denatured alcohol, if there are VOCs, but it's got to be something along those lines. Who knows what VOC is? What it stands for?
Volatile.
Organic compounds. Yeah. And they off gas, and so it was a big thing for years. Prefab homes, like single and double wide homes, manufactured homes, were busted out as fast and as dirt cheap as they could possibly be made with a lot of particle board. And particle board was made with a lot of formaldehyde. You know, particle board is just particles put together in a mold with a whole lot of chemicals and glue to bind it all together. And part of those chemicals, formaldehyde, and formaldehyde is a pretty noxious chemical, and it off gases. It off gases for years. So the interior air quality of these prefab units were pretty bad and caused a lot of people get sick. And subtle, you know, over years. So those are the things you want to watch out for, especially, and that's where SDS is really come in handy. So we're on to some pretty good stuff. And guess what? Guess what? Somebody guess. Let's get the people at home to guess too. What incredible thing am I about to tell you, impart to you? What thing that you've all been waiting to hear? What is it? Come on. Dylan, what have you been waiting to hear? Joel?
Measuring tapes?
No, but we're gonna be touching that today. Yeah, we're going into tapes and scales and stuff like that. But what's the thing you've all been waiting to hear? Joel, do you know?
We can use calculators.
Yes. Say it again, John.
We can use calculators.
Yes, you can use calculators. You can use your calculator, you can use your phone. You can bring a calculator, run a tape. I personally run tapes on virtually everything. I was going to bring my calculator tonight, but I decided not to because my phone will work for what we're doing. But we're past the doing the stuff by hand. I'm convinced you all know the principles of doing longhand addition, subtraction, multiplication, and division, and whole numbers, mixed numbers, which is mixed whole numbers and fractions, as well as decimals, all that stuff. And now we're going on to units 15, 16, 17, and 18, which are lineal measurement is 15, 16 is area measurement, 17 is volume, or cubic measurement, and I can't remember what 18 is, but did we just get somebody new just come in? Anybody they don't have? Did Adier make it, or Miguel Barbosa? No? Or Adier? Because only two guys are missing. So let's go right to, while I won't have a chance to tell you, I'll send out an email, and this is not for this class, but for the guys in this class that are taking 110. None of you are taking 110. Correct. Right? Are you taking 110, Angela? No. None of you are taking 110. Some of you are taking 110. Jacob, you taking 110? No. Michael is, Eric is, Brandon is,
Yes.
and Zach is, right?
Yep.
Okay.
Yeah.
So we're going to have another lab at the school from 9 to 1. 9 to 12. 9 to 12 if you got to leave this coming Saturday, day after tomorrow. And that lab is going to count as a makeup for Jim's lecture on Wednesday night. And that lab is going to be about placing the concrete. There'll be a transit mixed truck there, and we're gonna wheelbarrow the concrete in, and we're gonna screed it, and we're gonna vibrate it, a little bit, not really vibrate it. We're gonna work it and finish it and maybe do a control joint, maybe not, but we're gonna pour that this Saturday. Jim's gonna be in charge of that. That'll be his yesterday's class for 110 that he didn't have because he was sick. Okay, so those are the, you guys know that, and just, and on all of you, please check your pipeline. Just stay, that's the way I'll communicate with you, is through your pipeline email.
Rod, do you happen to know, is it gonna be like how you did where you took videos posted on YouTube, or is it gonna be a live Zoom link?
For Saturday?
Yeah.
Yeah, it will not be a live Zoom link. So, so if you can't make it on Saturday and you're in 110 this Saturday, you will need to watch the videos, and I'll probably get them up on Monday. I'll get them up on Monday and just let Jim and or I know that you watched that class. So if you can't be there Saturday to make up Jim's Wednesday, you can take it asynchronously, and we'll trust you to tell us that you've seen it. And by the way, we both Jim and I can know whether you took it or not. We can both know. We can know if you, well, we can know if you clicked on it. That's all we can know. We can't know if you really saw it. But there's a program, I was alluding to this the other day. I don't know if it was in here or where. I think it was at the site on Saturday. But there's a piece of software called Proctorio. You guys know about it?
Yeah.
You know about it? Do you know a little bit about it?
Patrick talked about it at the beginning of the semester.
Do you guys know about Proctorio?
Yes.
Yeah.
So I'm never going to use Proctorio. I think it belongs in George Orwell's 1984. It's the most unbelievable thing you can imagine. Now, actually, the interesting thing is I have clicked on a couple of tests. I don't use Proctorio, but I've clicked on a couple of yours tests. Well, one guy that I'm trying to get back in the class is having some problems. And it tells me how long he was sitting there, how many questions he answers, when he stopped, how long he stopped, when he came back, what question he started again, if he skipped questions. I mean, a whole bunch of information that I didn't have before, which truthfully, I'm not going to micromanage how people take tests. But Proctorio, if you have Proctorio, if you're using it, if I was using it, I was an instructor, I'm going to have you guys do the test, just like you do the test, right? Only I'd be using Proctorio, and you would have to sign or agree to let Proctorio in your life, because Proctorio would be in your life. Proctorio would be watching you, whatever you were doing with that test, and it would be counting eye blinks, looking away from the screen, any other heads in the screen. Oh, it's unbelievable. It's, to me, it's like, I would never, ever put that on you guys, nor would I ever want that put on me. Personally, I think it's one of the biggest violations I've heard of. It's not something that's ever going to happen to me. So, trust is a really great thing, isn't it? I trust all of it. I trust you to tell me the truth. And you know why I trust you to tell me the truth? You know why I trust you to tell me the truth? Because I don't know that you lied to me. And everybody starts out with a clean slate of 100% trust. And until you violate that trust, I think it's pretty much that way with everybody. You get trusted. And then if you violate somebody's trust, then generally you're not trusted. But the beautiful thing about trust is earned. You can earn someone's trust back. But let's not violate it in the first place, okay? No violations today. We're gonna light up this board. We're gonna bring the book. We're gonna start going through the book. Here we go. Share screen. Share.
You want us to turn off one light?
Let's try it with just one light. Yeah. Getting ready to fire up. Here we go. We'll go to modules and what are we doing? Oh, sorry. We're starting with linear measurement right out of the book. Right out of the book. The online textbook. Okay, so after Here's what we're going to try to do with this unit. After we study this unit, we should be able to perform linear measurements using the US customary system, which is the one you're all familiar with inches and feet and yards. That's the US customary system. We're going to demonstrate the ability to read an architect scale, just like this. You guys aren't seeing this at home because it's Zoom, because you're seeing my shared screen, but everybody in here is seeing an architectural scale, which I'll show you next time I get pinned. I'll show you. Oh, there used to be a bunch of them in here. Mine's kind of an oddball because that's what you don't want to have. And I'll show this to you too. That's an engineer scale. We're not going to teach you how to read an engineer scale. Desk. That's beyond belief. Anyway, that's an architect scale, and we're going to go through that tonight. How to read one. And there's some close-ups in the book here. And we're going to convert lineal measurements between units. We're going to learn to convert inches to decimal equivalents in feet and to convert decimal equivalents in feet to fractions of feet. The ability to read and rule. To read a rule and make accurate measurements is a fundamental skill required of all workers within the construction trades. I mean, as fundamental as it gets. Reading a tape, understanding what you're reading, adding up different dimensions, all this measuring and calculating, but being able to read a tape and architectural rule are some of the basics you've got to get down. Lineal measurement is the most basic form of measuring. It's defined as measuring in a straight line between 2 points. Carpenters must have a full understanding of the US customary system and also be able to read measurements on a set of prints using an architectural scale, an architect scale. The ability to proficiently convert lineal measurements is necessary to ensure accurate calculations on site. So here's the US customary system. Primarily used in the United States, requires you to accurately measure using a standard measuring device or scale. Because of this, you must understand how the system works and become very proficient in the use of it. So, there's our inches, 12 of them make a foot, yards, 3 feet. That's pretty basic. I suspect you all know that. Each inch within the scale is then broken up into fractional parts of an inch. So, again, we've all seen tapes, and you're not seeing this, and we'll show it later, but right, there's a tape, and it's going to show a tape, and it's broken up into fractions of an inch and feet and inches, and then all the way down here into eighths and sixteenths. Calls them out. Just looks pretty much exactly like that. So they're called graduations. I always thought it was gradations, but it's not. It's graduations. So the scale can be used to make precise measurements. Cutting an inch in 2 equal parts creates a ½ inch line. Cutting it into the 2 halves equally creates 1/4 inch lines. Cutting the quarters equally creates 1/8 inch lines. And finally, cutting the eighths in half creates 16th inch lines. So typically, we work in construction to a 16th. Some trades work to less than that. You can, if you can see it from my house, if you can't see it from my house, then it's close enough. But I try to work to a 16th, and most good carpenters try to work to a 16th minimum or less, even 30 seconds. Rarely 64ths, unless we're machining. If we're in a shop environment and we're machining parts for fine woodworking, cabinet making, millwork, then we might get to 64ths. But rarely, and we'll never get to hundreds or thousands. Even though, if I ever get to take it in my shop for that field trip, I have a saw made in Switzerland that cuts to thousandths and thousandths of an inch. It's got a digital readout. It's adjustable in thousandths of an inch.
How do you check for 30 seconds? How do you measure? Is there a special tape or?
No, typically you just go in between your 16ths.
Okay.
Right. So if you're falling right in between 9/16 and 5/8, you can call that 19/30 seconds.
Okay.
Right. And if you're one side or the other, we typically call it, rarely in construction do you hear 30 seconds.
Mm-hmm.
You might hear things like hairs called out, like blonde ones, black ones, and red ones, just a hair, so 15, 7, and 9/16 plus. is just the other side of 9/16. Call that a 32nd.
Mhm.
Or 9/16 minus just the other side of 9/16, right? That, and you get a language going with the guy measuring and the guy cutting, so you understand what you're talking about. And you go, yeah, just a skosh this side of, 5/8, and how a blonde one, a red one, or a black one? Black one's thicker, blonde one's thin, red one's the thinnest. Those are hairs. That's just some colloquial slang that carpenters use. But rarely do you call them out in 30 seconds, but you do, that's how you use them. Usually as plus. 14 7/8 plus would be 14 and 15 30 seconds. No, 14 and 7/8. Come on. 14 16 would be 29 30 seconds. Okay, so to help identify the value of gradations on a rule, lines vary in length, and that's typical of all your architectural rules, especially in the inch place. We're going to get to that in a minute, but in your tape as well. If you look at a tape measure, well, you can see this is pretty good illustration of it right here. The longest lengths of the graduations are in the whole inch. The second longest is in the half inch, third longest quarter inch, fourth longest 1/8 inches, and then the shortest are the 16th. So you get to know your tape measure. You know that, oh, if it's landing on one of those short numbers there, that's going to be in the 16ths. All fractional inch measurements will reduce the lowest terms. For instance, the 16th inch lines with even numbered numerators will always reduce to an 1/8, quarter, or half if they can. So you will never write a fraction like 4/16. You just won't. Just like you won't write 8/16, you won't write 12/16, right? You will reduce it. Because even though you'll be right, even though 12/16 is 3/4, and we go, what? What do you mean? Even though somebody should be like, oh, yeah, did you mean 3/4? When an object is measured with a scale, its length is determined by sequentially reading the gradations first in whole inches, determine the fractional value, and then combine the two. For instance, what's indicated below? What is that right there? Well, it's 10 whole inches and a half a fractional. So we say that is 10.5 inches. That's pretty basic. I know it is. It's very basic. I love the illustration though. Really. Okay, so architectural scale. Who's got a white one on it? Everybody? Yeah. These are all scale rules, okay? That's a scale rule. I like them flat. It's different than the ones they've been describing, but this one fits into my clipboard really well. And it has quarter, 1/8, half, 1, and that's what it's got. But here's the one. This is what I have. I have a 3/4 architectural scale. This is the one that you usually see. This is so bad. That's the one you usually see. It has 11 scales on it and 1 inch. So this is 3-sided, right? There's from each side is a scale. So there's 12 ways to go. There's only 10, and then this guy here. This is just one. This is inches and 16ths. So they all have inches and 16ths. They all have that, up to 12 inches and 16ths, and then they have scales. They have 1.5 equals a foot, 3 inch equals a foot. They have 3/4 and 3/8 equals a foot. It has 1/4 and 1/8 equals a foot, it has 1/2 and 1 equals a foot, and it also has 3/32 and 3/16. These are architectural scale rules. They look just like that, right? Now, doesn't this one look exactly like that? Yeah, it doesn't, does it? It does in a way, but it's not, because this is an engineering scale. And it's not, doesn't have the architectural scales that we want. It has something completely different that you're going to find in the engineered drawings. So don't get an engineer scale, get an architectural scale, unless you're planning to go into engineering. Then by all means, get an engineer scale. We're talking about architectural scale rules. I really like the flat ones. I have some big flat ones. I have all kinds of different size and shape ones. I happen to like that one. Okay. Anybody come in? Adair, did you come in? No? How about,
I came in,
No.
Miguel.
no? Okay.
Yeah, I just got off work, sir.
Okay, so in reading an architect scale, it's a specialized device used in architectural drawing. Scales were used by architects to draw blueprints. Before the development of computer-aided design and drafting, CAD, right? Computer-aided design, CAD, and drafting, which is what everything's done on now. But I draw by hand. I don't draw on a computer. I have drawn on a computer. I know the rudimentaries. I know how to do it. I'm not proficient at it. I don't know if I told you this, but I met a week ago, Friday night, the county architect for Santa Barbara. Can't for the life of me remember his name, but he's the county architect. And we had this conversation, and he draws by hand. It makes him feel closer to the work. And then when he gets done drawing by hand, he gives it to his guys to put on CAD. And that's pretty much where I'm at with it. I like to draw by hand because it makes me feel like I'm really in touch with what I'm designing personally. And that's also how I learned way back when in 1962. 1962 is when I learned to draw from Mr. Anscombe, B.O. Anscombe. Floyd Anscombe was his name. Anyway, architect scales are still useful in determining lineal measurements on a set of prints. So you'll use them to take off on prints. We'll use them. If the call out's not there, you can use the architectural scale to measure, to get lineal feet, get areas, all kinds of stuff. Because large construction projects cannot easily be drawn full size, like period. Drawings are drawn to scale, and they're typically drawn 1/4 inch equals a foot, and that means the 1/4 inch in the drawing represents 1 foot in the actual project. And so you can see on this regular architectural scale, every scale has a scale that reads from right to left and one that reads from the left to the right. In this case, we're looking at the 1/4 scale. And on the other side of it is the 1/8 scale, and that reads from left to right. So on the 1/4 scale, when we read from right to left, right there is the 0, right where my finger is, the 0. And then there's 2 feet, 4 feet, right? Some 2 feet increments. That right there is a foot. It's just not, the 3 isn't there. So 5 isn't there. So it's 0, 1, 2 is there, 3 is not there, 4 is there, 5 is not there. Get me? And actually, these short hash marks are reading the 8th way. So that one, it's really hard to see. It looks like 60. That would be 60 feet in 1/8 scale. But if you're reading on the 1/4 scale and you were right on that, reading 1/4 scale from the right to the left, it'd be 15/6 if it was right on that 60, because that's half. That 1/8 is half of that 1/4. So you know that half of a 1/4 or 1/8 of an inch is 6 inches, because 1/4 of an inch is 12 inches. So an 1/8, which is a half of a 1/4, is 6 inches. What's a 16th? Probably be 3 inches, right? Half of an 1/8. Okay. So in actual scale. So architect scale has 11 different scales on its tri-shaped body. One edge of a scale has a standard 12-inch ruler graduated into 16ths. The remaining edges of the scale will have 2 rows of numbers running in opposite directions. I just told you all about that. Each has a different number of gradations. And by the way, each individual scale always reads from 0 towards the whole numbers, but also from 0, either right or left, is 1 foot in inches on every scale. So if we go to this one here, quarter scale, you see that 0 right there? To the right of that are 12 hash marks indicating 12 inches in that foot. So if you were going to measure something that, let's say 20'6", or make it 20'3", you'd be on your 20 there, and then you'd read the other end would be on that hash mark there, that 3. It's kind of hard. It's easier to see on a real scale. Each row of numbers has a 0 at the end, identified with the scale designation. Each individual scale is always read from 0 towards the whole numbers. We heard about that. Now, we're going to convert lineal measurements. So the 3/4 scale, which is a really good scale, by the way, it's a scale that I like to use. It's a scale I like to use because it's big enough that you can show some details in, and you can show actually ½ inches. Because there's 24 lines within that foot, that 0 with those hash marks that way, that represents a foot in scale and 3/4 scale. There's 24 marks, which means there's a mark for every inch and a mark for every ½ inch. So you can show ½ inches now. So if you want to show a 3½ inch wall, you can show a 3½ inch wall. You know, even in 3/4 scale, you're not going to get a ton of detail. You're going to get some detail, but you know, you can be either side of a 7mm pencil line, and it's worth an inch. So you get close. That's why the call outs are the best. So if you have a call out on a set of plans, it's 6'7" and 3/8, and it's not there, but it's drawn to scale, and you try to scale it, you're probably not going to get 6'7" and 3/8. You know, reading a quarter scale, it's just not going to happen. You know, you'll get 6 foot, maybe you can figure 6'7" on it if it's really done well and sharp image that you can see. But that's why the call outs are so important on plans. And that's why they say, don't scale the plans. Use a call out, use a call out, use a call out. And there's plenty of places where you can use and want to use a scale, and we'll get into those too. So to use the architect scale to measure, find the desired scale on the rule. The 0 will identify what direction the scale is running and which of the 2 lines is to be read. The object to be measured is always measured by placing the 0 at one end of the object and reading the whole feet on the other. If the measurement falls between 2 whole feet, slide the scale back to the lower of the 2 feet and read the distance in feet and inches. And we'll do some demos on this as we get a couple more classes along. We're going to have a plan spread out, and we'll have plans up here, and we'll do some actual takeoffs. We'll measure and figure square area, we'll figure cubic area, we'll figure yards, we'll figure lineal feet, a plate, we'll figure things like, you know, like, for instance, if you want to figure the studs in your project, figure the lineal feet of your plate. And if you figure the lineal feet of your plate, you just figured out how many lineal feet of all your plates, of which there are 3, top and 2 tops and 1 bottom, and you will figure all your studs, because you can figure a stud a foot. That's how you want to order this job. If you roll that out, or you know, measure or add up all the call outs on a floor plan, and you're going to frame the whole thing, let's just talk about exterior walls right now. Or you can even do interior walls, it doesn't matter, all the walls. But you get the lineal feet of the walls times 3, that's how many plates you order in 2x4, if we're doing 2x4 walls. But that's also how many studs you order. Even though studs are every 16 inches, which is every 1 1/3 feet, you go every foot because of blocking corners. Your corners take more than 1. I got some sheets I'll hand out later, not in this class. I'll project them and show different corners, acceptable framing corners. Some use more studs than others, but a stud to a foot. is the deal. And then you get really cool things like joists, right? Joists, you take the linear foot of the joist run. Let's say you got your joists are 2x10 joists, 16 on centers, and they're running this way, and they're 14 footers, and they're running over 48 feet of distance. You take that 48 feet times 0.75 and add 1, and that's how many joists. It's a simple formula, 0.75, and that works on 16 centers. I can't explain the math, even though I've never tried. I probably could if I really tried to break it down. I haven't. So what distance is identified on the scale? Somebody tell me. Right there that we're looking at. What distance is identified? Don't read it. Come on, you guys can all see it. What distance is on there?
Okay, on the drawing? Just on the-
Yeah, no, right here. What distance is that? From that point
Can you zoom in a little bit?
on the drawing, this is in 3/4 scale. You're reading the scale rule right there.
1.25.
Say it again?
1.25.
No, it's 2 foot, 3 1/2 inches. There's your from 0, 1 foot, 2 foot. It's over 2 foot, so you get, so it's the points it's on is on the 2, and then the inches are over here. And if it falls there, it falls on the 1/2 inch past the 3.
Oh, that's right.
So that, which means it falls 7 ticks past the 0, which is exactly 3.5 inches. And lo and behold, I was right. 2 foot, 3.5, right? 7 lines to the left of the 0. You're not going to be counting lines though, because you're going to see readily when you look at that, when you're reading scales, when you look at that 3/4 scale, you're going to see where my arrows are. That's 3 inches, 6 inches, 9 inches of the. It divides an inch into quarters. I'm sorry. It divides a foot into quarters of 3 inches each. And then of that 3 inch, you can see 1/2 inch 1, 1/2 inch 2, 1/2 inch 3, 1/2 inch 4, 1/2 inch 5. Get it? Okay, good. Converting lineal measurements. This is really calculations within the construction industry will often require numbers to be converted from one unit of measure to another. To convert any number from feet to inches, simply multiply by 12. That's the number of inches in the foot. And okay, so for example, 6 feet to inches, pretty easy, right? 6 times 12, 72 inches, easy. Convert 4 foot 7 to inches. So to do that, when it has feet and inches, you need to multiply the feet by 12 and then add the additional inches. So if we're going to convert 4 foot 7 to inches, 4 foot times 12 is 48, and then we add the 7 inches, 55 inches. Piece of cake. Convert 36 inches to feet. 36 divided by 12 is 3 feet. When converting from inches to feet, the number of inches being divided by 12 may not divide evenly, leaving a remainder. If the answer can be expressed in feet and inches, the remainder simply becomes the inches. So 42 inches to feet is 3 foot 6 inches, or 3 foot 6. U.S. customary system uses fractions as part of a whole, but often mathematical calculations are performed using decimal fractions, and we're going to see how that works. Because of this, the ability to convert inches to decimal equivalents and feet and decimals to fractions by proportion is essential. So I'll reread that slower. Because of this, the ability to convert inches to decimal equivalents in feet. So what's the decimal equivalent of 3 inches in feet? So it's 3 over 12, right? 3 inches over 12, which is what fraction? That reduces. You wouldn't say 3/12, what would you say? 1 quarter. 1 quarter as a decimal, 4 into 1 is 0.25. Right? It's easy. And we're going to go through how easy it is here. I'm just going to remember a few things. it's essential to be able to convert inches to decimal equivalents and feet and decimals to fractions by proportion. It is essential. So I think we got, let me see, we'll just get through the next, yeah, there's just 2 pages before the review, then we'll take a break. So, so converting inches to decimal equivalents in feet. Calculations may sometimes require you to convert inches to feet, with the remainder being listed in decimal equivalents of a foot. Since there are 12 inches to a foot, any number of inches in the remainder divided by 12 will provide an answer in decimal equivalents of a foot. And here's an example. In converting 75 inches to feet, it's 12 into 75, which if you just do the math, and the same thing should happen exactly on your calculator, is if I take my calculator and go 75 inches divided by 12 equals, that didn't come out right. 75 inches divided by 12 equals 6.25. So it's 6.25 feet. And then your calculator will give that to you right then. Boom, just like that. 12 into any number of inches is going to give you the feet, and the remainder is going to be in inches, or it'll be a decimal equivalent of a foot, if that's what you want. So really, then rather than give somebody the number of 6.25 feet, if you're in construction, you're probably going to want to get that 625, and we'll cover this in a minute as we go along, convert that to a fraction. Because people, somebody's going to have to convert that. Not that 25 is hard to convert, or 0.375, or any of those 0.125, 0.375, 0.625, 0.875. Those are all the eighths. And then, of course, the quarters, 0.25, 0.5, 0.75. Not a lot to those fractions. So, converting decimal equivalents in feet to fractions. Situations will arise when performing calculations when the lineal distance ends up in the form of a decimal foot. It must be converted to a fraction of a foot, so it can be measured with a tape measure. So to convert 14.786241 feet to fractional feet and inches, here's how it's done. First, remove the whole feet from the number. So set that 14 feet aside. We know 14 feet, that's not going to change. It's going to be 14 feet. What we need to find out is what 0.7862.41 foot represents in inches. And to do that, we just multiply the decimal by 12 inches. So the 0.786241 feet times 12 inches equals 9.43482 inches. So pull out the 9. So now you've got 14 feet 9, and you've got a 0.434892 as a decimal that needs to be represented as a fraction, because you can't cut that on your tape. You need to read fractions on your tape. So all we got to do there, because we want to find out 16ths is what our tape is, the graduations of our tape, is just do that 0.434892 times 16, and we get 6.95, right? And 6.95, we're going to round up. Anything from 5 up. So we're going to round that to 7. And that's not 6.95 feet. That's 6.95 over 16. That's 16ths. Rounded to 7 because we can't have 0.695 16ths. We got to round. So it's 7/16. So the answer is, we go back to 14, which we put aside, the 9, which we got, 14 foot 9 and 7/16 of an inch. That's the answer. Piece of cake. And then converting decimals, converting decimal equivalents in feet, often in the construction trades, the diagonal measurements of a square or rectangle need to be calculated and then measured to check for square. This needs to be performed on walls, floors, decks, laying out corner sticks, etc. The process to determine the length of the diagonal is covered in Unit 21, right triangles. The wall shown below has already had the diagonal measurement calculated, but the answer remains in the form of a decimal equivalent to a foot. Using the process to convert this number to a fractional foot will produce a measurement that can be found on a tape measure. So let's convert this whole 32 feet, 0.984845. So that's the long ass decimal number. This took it out to. I'm sure a calculator did. So we know it's 32 feet. That's not going to change. So we need to convert the 0.984 blah, blah, blah to inches, basically, right? To 16ths of an inch. So to determine the inches, we need to multiply the decimal by 12, and then we get that 11.81 blah, blah, blah. So it's 11 inches. So we're pulling that out. 32 feet, 11 inches. And now what we got left is this 0.818 blah, blah, blah. That we got to do it times 16. And again, aren't we glad we're using a calculator for these and not doing them longhand? Man, I am too. We're going to come up with 13.09 blah, blah, blah. So that 13, if it was 0.5 something, you'd round it to 14. But since it's below 5, we're going to round it to 13. So that 13.09 blah, blah, blah becomes 13 what? 16ths. Answer being 13 16ths, 32 foot 11 and 13 16ths. Get it? It seems somewhat complex, but not really. You've got to multiply times 12, then you got to multiply times 16. To get the inches, you got to multiply times 12. I mean, sorry, to get the inches out of the feet, and then to get the inches out of what the decimal that's left, you got to multiply by 16. It's going to get easier and easier the more you do it. And then here's a review. We'll whip through quick, but not right now. We'll take a break. I've got 5 after. Come back at 15 after. Let's just take a 10-minute break. See if we can't whip through a couple of chapters and then call it a night. What do you say? Are you good with that? Okay. And Zach, I'm nominating you to please tell me to record my volume.
Yeah, he's talking, but you can't hear.
Who is Jacob?
Zach. Zach's talking, but
Zach's talking.
we can't hear him.
What are you saying, Zach?
You need to turn your volume on the computer.
My volume's on.
I said it simultaneously.
I can barely hear him yet.
Oh, is that what it is? Now talk.
I said it simultaneously to Dylan, who's my chief advocate.
Oh, so you probably said it in Dylan's ear in a little earbud mic he's got, so he could say and get credit for it, right?
You're on to us.
I knew it. I knew it. Video's uploading on YouTube right now. Next door. Don't forget. All right. So anybody have any questions so far? It's all pretty basic stuff, right? So here's our review. All right. Matthew, what's the answer to number 3? Right there, number 3. Matthew, you still here? Matthew. Jesus.
For what? For number 3?
3, yeah. What's the answer?
2/1/8.
Very good. Austin, what's the answer to number 4?
2 and 15 and 16.
Excellent. Dylan, what's the answer to number 6?
Number 6 is 4 and 13 16.
Okay, I see. It looks like you guys have the grasp of that. Okay, so answers in feet and inches. D'Angelo, what's number 8?
8 is 8 and a quarter. 8 inches and a quarter. Oh no, sorry. 32. No, 8 foot. 32 inches and a quarter.
Feet and inches. 1 in feet and inches. We got enough information there. Look up on the screen. Too, while you look at the same thing in your books, right? What is that in feet and inches? Number 8. Feet and inches. How would you say it?
2 foot, 8 inches. and a quarter.
Very good. Very good. 2 foot 8 1/4, just like that. 2 foot 8 1/4. Okay, let's see, Ben, number 10.
The 3 feet. 3 feet on 7/8.
Of an inch, correct.
Yes.
11, John.
11 is 3 feet, 2 inches, and 1 inch.
Yes. 3 foot 2 1/8. Michael Silva, what's number 12?
Number 12 is 3 feet, 3 inches, and 5/16.
Very good. So I think everybody has a concept of that. I'm reading these tapes now. Let's look at this architectural scale rule here. So identify the scale measurement on the architect scales below. Express your answer in feet and inches. So number 13, John Tapia, what does that represent in feet and inches on that quarter-inch scale?
It is 6 feet and 2 inches, or
I think it's right dead on the 3.
okay, yeah.
So the longest lines are, 0 and then the 12. The second longest lines is at 1/2 inch. And that's 2 shorter lines are at 1/4 and 3/4. And then ones in between those are inches. So that's pointing right to that first kind of longer line there, past the 0. That's 3-inch line. That's right. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, number 14. Brandon, what is number 14 on that scale?
14.
The answer to number 14, that scale right there shows how many feet and how many inches.
2 feet and 6 inches. No.
Say it again, please.
2 feet and 9 inches. No.
You're really close. You got the first part was right, but it looks like a 9, but it's upside down. So come on.
A 6.
Yeah, 2 foot 6, exactly. 2 foot 6. You see it? The 2 foot right there. Counting from the left, right? 1, 2 foot, and then the inches are right now 6. And then 1 inch scale. It's divided into 48. So there's actually 1/4 inches. So it's 0, 1/4 inch, 1/2, 3/4, 1 inch, 1 1/4, 1 1/2, 1 3/4, 2 inches. You got much more detail available.
Which one are you reading?
Number 14,
Oh,
the 1 inch scale. Okay, let's go to 15. Now see, when you get into 1 1/2 inch scales, you're going to see those on plans in details where they want to blow things up and show you details to scale, but not full size or even half size. So Austin, number 15, what's the answer?
4 feet and 10 inches.
Well, you got the inches right.
Is it 3 feet?
Nope, it's 2 feet. Right? So there's 1 foot right there, right? 0 through 12, that's 1 foot. We're starting at 0, that's 1 foot, 2 foot. See this 2 here? That's coming from the opposite way from the 3 inch equals a foot scale. That's down here, that's bigger. This scale is closest to the top here, reading right. 1 foot, and it's in 2 foot increments. Remember, all those numbers on your architectural scale are 2 foot increments. They will show 3 and 5 and the even increments, but they don't number them. You have to figure that out. That's 1 foot, 2 foot, and then reading back on the inches. Very good, 10. Obvious, right? Dylan, what is number 16? What's the answer to number 16? How many feet and inches in that 3/8 scale is that line measuring from that point to that point?
6 feet and
One. How many is that broken up in 3/8 scale? How many from 0 to that hash mark? How many lines? There's 12 lines, which means each line represents what? 1 inch, right? 1 inch. So
6 feet.
where is that pointing?
6 feet 3 inches.
There you go. 6'3". Okay, so it's important. Those inches, you know, and you're getting, when you're scaling stuff and drawing stuff to scale, once you do it a few times and hopefully get a sense of it, it gets really easy, I promise. Super easy. Okay, what do we got here? We got some problems, all right? What's this? Okay. So we're going to convert the following units of measure to inches. Joel Santos, 2 foot 10 inches equals how many inches? Joel, did you ever come back from the break?
34 inches.
Boy. Very good. Everybody concur with that? So tell us how you did it, Joel. Describe the process. Joel. I know you can hear me because I heard you. Joel, can you hear me? Will someone describe the process and whereby Joel got this number?
You times 2 times 12, that equals 24, because 12 inches equals a foot. And then you plus 10 plus 24 is 34 inches.
Exactly correct. Okay, now, Matthias, while you're there, please convert 5 foot 3 inches to inches. How many inches?
63 inches.
Very good, very good. You guys see that? 5 times 12 is 60 plus the 3. 12 foot 8 in inches. Who wants to do that? Maybe who's at home? Daniel? No, Lou's Miguel. Matthew. Matthew, can you hear me yet? Matthew Aguinaga? All right. How about Joel? Can you hear me, Joel? Oh, you're not coming in, Joel. I'm talking. So how about you, John? John, what's 12 foot 8 inches?
152 inches.
Very good. Excellent. Okay. So you guys got this one, right? It's as simple as 7 foot 2.5 is 7 times 12. Find out the inches in 7 feet is 84. Add 2.5 inches, 86.5. 4 feet is 48 plus 4.5 inches is 52.5. This is all pretty darn simple, right? Convert the following units of measure to feet and inches. Okay, 73, Dylan. Number 22, the one that's showing right at the top. 73 inches is how many feet and inches?
Feet. 6 feet and quarter.
Damn it, Dylan. So what's 6 times 12?
6 times 12. 72.
Okay, that's the shit that you need to get in your head and start really. You don't want to get it by practice because you're definitely way smarter than you need to be for this stuff. You just haven't practiced it enough, right? So in something like that, you're going to want to convert that right away, right? Because you know that 6 times 12 is 72, and they got an inch left over. So 6 foot 1. What about Dylan? What about do the next one for us? What's 41 inches in feet and inches?
3 feet and 11.
How about 3 foot 5?
3 foot 5.
Because 3 feet is 36 inches, right? And 36 inches from 41 is 5 inches. And if you were using your calculator, you would just go 12 into 41, and it'll come out with 3 and a remainder, right? And then that remainder will be shown as a decimal on your calculator. So then you just go 3 times 12 is 36, and then take your 36 from the 41. All that stuff, same stuff, right? So let's skip to 109 3/4 inches. Austin, what's that feet and inches?
9 feet is 8 inches. So you're going to have 1 inch and 3/4 left over. So
So
9 feet, 1 3/4.
Exactly correct. 9 foot 1 3/4. So when you're giving somebody a measurement, right, of something to cut, and you throw your tape on it, and your tape says 109 3/4, you could tell him or her, whoever's cutting for you, 109 3/4. Now it'd be fine. They just wrote that on the tape. Or you could say, because a lot of carpenters are used to feet and inches rather than inches. Cabinet makers are way more interested in inches and millimeters and centimeters than carpenters. Carpenters generally like, we read plans in feet and inches, we call out stuff in feet and inches. So rather than 109 3/4, you'd probably say 8 foot 1 3/4. And really, and everybody's tape says that, right? So when you go to, if you need to figure that out in a hurry, you just pull out your tape and go to 109 3/4, and right there you can go back to the left. It says 9 foot 1 3/4. Every tape is going to give you the feet as well as the inches, on one side, and then the feet and inches on the other side. 57 1/16. John, what is that, feet and inches?
4 feet 9 1/16.
The grasp of that. Now let's convert the following units of measurements to decimal equivalents in feet. Oh, did we get to that yet? I think we did. Okay, so convert the following units of measurement to decimal equivalents in feet. Round to the thousandths place if needed. So let's do these on the board. We're going to do these on the board just so people can see how we did it. Because this part of the book, even though it's actually relatively simple, it gets a little confusing. So we're going to jump the share. Turn this baby off. Convert the following units of measurement to decimal equivalents of feet, rounded to thousandths place when needed. So we'll start with 35 inches. So 30. Okay. 35 inches. We want to convert it to what? We want to convert it to a decimal equivalent. So it'll be feet with a decimal equivalent. So to do that, the first thing we're going to do is we're going to divide it by 12, right? We're going to divide it by 12. So use your calculator. Tell me what that comes out. What's it come out? 2 point what?
2.91666.
916667. Okay, so what we know is it's 2 feet. So we're going to put the 2 feet aside. We know it's 2 feet. Now we need to know what 9.9. You know what? We've already done it. Yeah, we've already done it. That's right. We don't have to convert anything. We've already done it. So by using our calculator, figure the decimal equivalent of 35 inches in feet, feet in decimals, not feet in inches, not feet in fractions. We just divide 12 into it, and that's our answer. Now we need to round to the nearest thousandths. Tens, hundreds, thousandths. We go to the right. What is it? Is it, we're gonna go up or down? We're gonna go up. So we're gonna get rid of those and make that, yeah. So the answer is 2.917. Oh, what do you know? That's the answer I got too. Okay, the next one is 27 inches. 27 inches divided by 12. Now I'm gonna, don't, that's gonna be 2 foot, 0.25. Go ahead and bear me out on that.
2.25.
Yeah. You see how fast I did it on my head? I did that because it's pretty damn easy. If you know that 2 times 12 is 24, and that 24 from 27 leaves 3 inches, and 3 inches is 1/4 of a foot. 4 inches is what of a foot? It's 1/3 of a foot, which is 0.333. What's the next one? 89 inches. Okay, 89 inches divided by 12 equals what?
7.41667.
7 what?
0.41667.
And then, oh, when we're rounding these out to the nearest thousand, 0.66, we're gonna round that up to 7. 7.417. And now you can check yourselves on that too, right? If you just wondering, did I get that right? Well, you know that 12 goes into 89. 12 times 7 is 84. You know that because you know your times tables, right? So that leaves 5 left over. So basically it's 5/12, which is less than 6/12. So it got to be less than a half. So 0.417, 0.5 being a half sounds pretty reasonable. So I'm down with it. I like it. Besides which, if your calculator told you that's the answer, then if you punched in the numbers right, you're going to get the right answer. What's the next one?
49.
49. 49 inches divided by 12 equals what?
4.08333.
And then we're going to drop off those 3's because it's below 5, right? So we're going to just leave it 3. So 4.083 feet. The denominant is pretty important, as you remember from our midterm test. And I will tell you on a test how to do the denominants, what I'm looking for. Really, what I'm hoping to tell you is what Canvas is looking for. But the denominant is pretty important. And how you write feet, you know, I am really used to writing feet like that. And I'm really used to writing inches like that. And it's pretty universal, and it's pretty much know what I mean when you see that, right? It can also be written as 37 FT, 37 F. You just got to agree on whoever you're working with, what you guys use. But generally, I use feet and inches in virtually everything. And if I'm doing square, which we'll get to, it's either going to be square inches, square feet, but I personally like square feet, square inches. That's my code, right? My square and either a foot sign or a square and an inch sign. But that code needs to be recognized by everybody that's important, that needs to know it, right? And if you got somebody going, well, I've never seen that before, then it's not too good, right? Not too good. Everybody's got to be on the same page with this stuff for it to work. And that's what is so beautiful about math, is it doesn't care. I think math cares whether you're hungry or not. No, it doesn't care. It's this pure science. It's just like,
I knew a guy who was a defense attorney, and he always hated the fact that at the end of the case, he always kind of sat there and said, maybe there was one other solution, or maybe there's one more thing that I could do. And he actually became an accountant because at the end of the day, once the books were closed and everything, he knew that all the numbers were correct and there was no other way around it.
yeah, because numbers don't lie.
Numbers don't lie.
Defendants do.
Yeah.
Or worse. That's good though. I like that. Not recording? So paranoid about it now. Did all those. Okay, now this is fun. We're going to convert these guys into fractional feet and inches. So we're going to do the first one. We need to convert 9.78531 feet to feet and inches, to fractional feet and inches. In feet, oh, I'm sorry, decimal equivalents in feet to fractional feet and inches. Well, here's how you do that. We're going to do this one on the board too. We're going to do these on the board. So, yeah, you guys, I'm sorry, I started that share. Back to the pin. Okay, that first one. What is it? It's 9 point. Somebody read it off to me, please.
9.78531.
Yeah, see that? You see that, huh? Okay, so we want to do this in fractional feet and inches, right? So to do that, we're going to pull out the 9. So we know it's 9 feet. We know that's happening, right? Now we need to know what 0.78531 is in inches. So all we got to do is do that times 12. What's the answer? 12 times 0.78531 on your calculator.
Times 12?
Yeah, point, not the 9. 9 is feet. We've already pulled that out, right? Now we just going to go 12 times 78531. What's the answer? 0.78531.
9.43, sorry, 42, well, 9.42372.
9.4372, correct?
423.
Please again.
423. 72.
72? Okay. So that's inches. We just did it by 12, right? We just did it by 12. So it's 9'9". And now we've got the 0.42372. We need to know how much that is in fractions of an inch. We're going to use 16ths. So we multiply 0.42372 times 16. What is it, please?
6.77952.
Okay. Now that's 6.77952 16ths. Is there such a thing? No. We're going to round up, which makes which we're going to round up to the nearest 1 on the left side of the decimal. So what does that make this number when we round it up?
7.
Makes it 7. Right? So this becomes 7 over 16, which makes the answer 9 7/16. Right?
Yep.
So this is a process. As long as you know the process, you're cool. So we'll do a few more and we'll get this, we'll get through this process. So we did that one. That's a good one. The next one is we want to convert, read that off to me, please. Number 33, 11.
11.28 491.
491, that's the number? Okay.
491.
28491?
Yes.
Okay, so it's represented as a decimal, feet as a decimal. And we want it to go feet and fractional inches. So we know that it's 11 feet, right? We can just pull that right out. So we'll make that 11 feet. Now we just need to know what 0.28491 is in inches. So please, 12 times 0.28491.
3.41892.
Okay, so it's a 3-inch part that we really like. So 11 foot 3. And now we need to just take 16 times 0.41892. What do you got?
6.702.
Which makes this 6, we're gonna round up the 6 to
7.
over 16. 11 foot 3 and 7/16 is the answer. Okay, let's skip, since we're getting the hang of this, we'll skip down to the last one, number 36. Could you read question 36 off for me, please?
12.56471.
Like that?
Yes.
Okay, so it's 12 inches, that much, I'm sorry, 12 feet. You know that. Now we're gonna do 12 times 56.56471. What do you got?
6.77652.
Okay, so it's 6 inches, 12 foot 6. Now we're gonna do 16 times 0.77652. What do you got?
12.42432.
We're gonna round this to the nearest whole 1. So that becomes what? 12. So it's 12 over 16. Can we leave it at 12 over 16? Can we write 12 foot 6 and 12 sixteenths? No, what is 12 sixteenths?
3/4.
3/4, right? 4 goes into 12 3 times, 4 goes to 16 4 times. 12 foot 6 3/4 inches is the answer. So that's how you do that. And that takes us right into perimeter measurement. Woohoo! So let's get right to it too. Perimeter measurement. Okay. After careful study of this baby, we should be able to calculate the perimeter of a square, calculate the perimeter of a rectangle, and calculate the perimeter of irregular polygons. Purchasing materials for a project will often require you to calculate the perimeter. We just talked about that. I gave you an illustration about times 3 on the plates for a perimeter of walls, and the counting of the studs at 1 foot per stud. So calculating the perimeter of buildings and structures is very important. So you need to know how to do that. It's not hard at all. Whether it's a square is the easiest, rectangles are second easiest, and irregular polygons are also pretty easy too, especially triangles. And we break up everything so we can get the square footage of every, well, perimeter is one thing, that's pretty darn easy. Actually, perimeter is pretty easy, and then we get into areas, we are gonna break that up somewhat. I'm gonna break that up into squares, rectangles, and triangles. So the perimeter can be measured on any enclosed geometric figure or polygon. A 14 square foot room can have its perimeter measured for base molding. A rectangular foundation could be measured for sill plates. An irregular shaped roof could be measured for drip edge. Perimeters are usually measured in lineal units of feet and inches. So a square is a four-sided polygon, has equal measurements on all four sides at 4 90-degree corners. So using the side length, two formulas can be used. The square's perimeter can be, if it's 4 inches, 4 times 4 times 4 times 4, or just 4 times 6.
Plus, right?
Pardon me? Yeah, plus, right, not times. How do you 4 to the 4th power? That'd be a lot different. 4 plus 4 plus 4 plus 4, or 4 times the side, if it's a fourth square. Rectangles. Well, okay, so here's an example of a square that's 6 foot on a side. You could add up all 6 feet for 24, or just do 4 times 6. The perimeter of a rectangle is a polygon with 4 sides whose opposite sides are parallel and equal in length. Like a square, its corners are 90 degrees, and two formulas can be used to determine a rectangle's perimeter, which is length plus width plus length plus width, or 2 times the length plus 2 times the width, which is the easiest way to go. And that's pretty easy to do in your head. 2 times 5 is 10, 2 times 12 is 24, 24 and 10 is 34. So that answer is indeed 34 feet. That's the perimeter of that 5 foot by 12 foot rectangle. Here's some irregular polygons, and you just got to look for where the numbers are, right? So you would just add up the numbers as you go around. Pick one. We'll start at the 7, and we'll go around clockwise. So we'll add the 7 to the 15, right? Going around clockwise, 7, and we'll add 15, which is 22. We'll add 5, which is 27. We'll add 14, which is 41. We'll add 9, which is 50. We'll add 14, which is 64. We'll add 3, which is 67. We'll add 15, which is 82. Am I right? Let's see. Let's
Maybe,
see.
yes, yeah.
I'm right. Oh my God, again, that's 2 in one night. Perimeter of the room is 82. When performing perimeter calculations, all measurements must be expressed in the same unit. So measurements expressed as feet and inches are often converted to a decimal form for calculating purposes. So when you're calculating the perimeter, you can do feet and inches. It helps if you convert the inches to decimal equivalents, and then you can just plug them into a calculator. Decimal equivalents. Otherwise, you've got to add up all the feet, and then add up all the inches, and then convert the inches to feet and inch remainder. Which a lot of that stuff you can do in your head, but if you're doing it on paper, it's sometimes easier just to convert the inches into decimal equivalents, and that's actually pretty easy, right? Just over 12, right? So 2 inches over 12, 1.5 inches over 12, right? How do you get the decimal equivalent of 2.5 inches? How would you find that? Anybody? Zach Higgins?
I'm here, sorry.
That's okay. How would you find the decimal equivalent of 2.5 inches?
You would chop off the whole portion. Wait, can you repeat your question?
Yeah. The decimal. What is the decimal equivalent of 2.5 inches? How would you find the decimal equivalent? That's actually, that's more important to me than the answer. So as in anything like that, all you got to do is represent it as a fraction, right? So 2 inches is 2 over 12, right? We're talking about inches or parts of a foot in 12s. So it's 12ths. So 1 inch is 1/12. 2 inches is 2/12. 2.5 inches, it's just 2.5 divided by 12. So make it into a fraction, and the top number divided by the bottom number is always the decimal equivalent of the fraction. Always the decimal equivalent. Let's take an easy one, right? Like 50%, like 0.5, right? Like or 6 inches, 6 over 12, right? 6 into, or 12, I'm sorry, the bottom number is 12, into 6 goes 5 times, but it's 0.5. 0.5 is, okay. I think you got that. I think you all got that. And the more you do it, the more you're familiar with these numbers and the simple computations like the times tables, the better you'll be at this whole thing. It'll start sliding right into your head. Once the footer and foundation of a building have been constructed, the sill plate is installed on top of the foundation and secured with anchor bolts. The sill plate allows a wooden structure to be connected to the concrete or block foundation. To determine the number of plates needed, start by determining the perimeter. So this one would be, 2 times 46 is 92. No inches to 0 inches. 2 times 32 is 64. 64 and 92 is what? 156?
Mhm.
Yeah, 156. And then from there at 156, you'd figure out 16-foot stock for your plates, right? Just divide 16 into it, 9.75. How many plates you're gonna get? How many 16-footers you're gonna get? You get 10.
10.
Right? You'll have a little bit of waste. You'll have 3 inches of waste. That's pretty good utilization of material. It's very good utilization of material. What's the perimeter of a garage that's 24 wide and 24 long?
96.
Exactly. Who said that?
Me, Miguel.
Hey, Miguel, dude, you made it.
Yeah, been here for a little while.
All right. I looked for you for a while there, but you're here. That's all that counts. I'm marking you here. Adair, did you come in? All right. And then Miguel, when do you work tomorrow?
7:30 till.
At some point, call me up when you're on a break or something. We can talk about the test and stuff. Okay. I know I haven't gotten back. Have you been able to take it yet?
Not, no, still locked.
Okay. Well, let's just be sure and call me sometime tomorrow. All right. And I'll make sure I get that thing so you can take it at your leisure. All right.
Okay, yeah.
Okay, good. Thanks, man. All right. So what's the perimeter of a house that's 32 wide, 66 long? Anybody? Come on.
196.
Very good. Is that right? 66 twice is 132 plus 64. Yeah, 196. Very good. How many lineal feet of fencing is needed to fence the perimeter of a yard? It's 60 foot wide and 155 foot long.
310.
Is that what it is? No, because twice 155 is 310. I got to add twice 60, which is 120. So that would make it 430. 430 feet would be your perimeter. Don't forget, you got to do both of them. So you see 2 times one side and 2 times the other side added together. Now this one requires you to use your head. So how many 10-foot sticks of drip edge are going to be needed to trim the entire perimeter of the roof shown below? Well, don't you agree that the first thing you need to find out is how many lineal feet the perimeter is going to be? And then we can divide by 10 to find out how many pieces of drip edge. So it's not just 2 rectangles, because we're not putting drip edge on the roof, on the ridge. We're putting it around the edges. So we know that if we do both of these and double them, we'll be fine. So 15 and 15 is 30. And then the 34, this run here is 34. 34 and 30 is 64. We're not using the ridge, and it would be exact same on the other side. So it's 128 lineal feet divided by 10 is 12 and 8 left over. So you better get 13 sticks, right? Mm-hmm. What's the perimeter of a room that's 12.9 and 14.3 long? So the easiest way to do that is to convert those to, there's actually easier ways for me to do it, but an easy way to do this is convert those to decimals. Those are easy ones to convert. What's 9 inches converted to a decimal? What is the decimal foot that 9 inches represents? 3/4. Exactly. 9 inches is 3/4 of a foot. 9 over 12, 3/4. And how about 3 inches? 3 over 12. What's that? It's a quarter. So 9 3/4 plus 14 1/4 is 27 feet, right? 26 plus the 3/4 and the 1/4 make, and then you can you kind of look at stuff like this. Look at the 9 and the 3. That's a no-brainer. The inches make up 12. So just add the feet and add a foot. because you know the inches make up 12. And by the same token, if that were 10 and 5, 10 inches and 5 inches, 10 and 5 is 15, which is 1 foot, 3 inches, right? 12, and then the 3 left over. So then do your math on the feet, add 1 foot, 3 inches. You can do most of that simple math in your head without using a calculator when the numbers aren't too long, especially when you get used to, knowing and adding up to 12 and increments of 12 and being able to convert to decimals when you need to, because really the converting 3 inches to a decimal should be like right in your head. 3 inches should register as 0.25 of a foot, just like 9 inches, just like 6 inches should register as 0.5. Those are pretty simple stuff that you should teach yourself, teach your mind to recognize like instantly. What's the perimeter of a closet that measures 63.5 long and 24 1/4 wide? We need to, an answer in feet and inches. Well, let's just do it together. So the perimeter, it's a rectangle, so we've got to add 63.5 twice. So that's 127. 2 63s is 126. 2 halves is 1, so that's 127. 24 1/4 twice, 2 24s is 48. 2 quarters is a half. So 48.5 plus 127 is whatever the hell it is. I can't do it in my head right now. I'm burnt out. Right? You get it? What does it come out to, by the way?
I got 175.5.
Okay, and we need it in feet and inches. So if that's the case, let me see. I just want to make sure that's right. I think I did all these. Which one are we doing? What number is it?
Number 6.
Yeah, I didn't do that one. Okay, so what did I say? 127, right? 127 plus 48.5. 48. Wait, that's not gonna work. 127 is, so it's gonna be 48.5. 127, full number, 63.5 twice is 127, plus 48.5, which I'm going to put 48.5, and that equals 175.5, just like you said. And now on my calculator, without doing anything else, I'm going to go divide by 12 equals 14.625. So that's 14.625 feet, but this needs to be in feet and inches. Right? So the simple way I do that is I just take what was the number we started with? If we divided it in 175.5. Okay. Okay. So I take 14 times 12 equals 168. I divide that from 175.5, comes out 7.5. So the answer is 14 feet, 7.5 inches. Okay. Got it? You got it, Dylan? Dylan, I'm going to be testing your ass on this. And just use your calculator, but as long as you know how to work this stuff, the calculator will make it happen for you. And so you just gotta picture in your mind that perimeter of that closet, right? 2 63.5s, change them into decimals, easy to plug in. 2 24 1/4 24.25 times 2. You'll get that 48.5. You'll add it to, and you'll come up with a 0.5, and you want to change that to inches. Well, you know that 0.5 of a foot is 12 inches, right? I'm sorry, 0.5 of a foot is 6 inches. And to find that out, it's just 12 inches times 0.5. Anytime you want to know, change decimal equivalent into inches, just multiply it by the inches. And then if you want fractions, that's 16, it's multiplied times 16. Okay, so I want to get us let's see, what is this? This is week 10. We have 6 weeks left, right? We have 11, 12, 13, 14, 15, 16. We have 6 weeks left. Now, final last week, so we have 5 weeks of class. Okay. All right, then here's your option. Take a 10-minute break, And we'll go for maybe another half hour, or we'll just press through for another 20 minutes and split. Which is it?
Press on.
Press on? Press on, that would be
Press
that would be my choice. Press on it is. The people have spoken. So we'll at 25 after, I'll just make an announcement or two and we'll shut it down. Okay. How many 12-foot pieces of wall angle are needed to install around the perimeter of a room measuring 52 feet 7 by 48 foot 10? Okay, so what's the process of doing that? Somebody explain it to me. Anybody, just unmute yourself, or somebody from here just start talking. How do we?
Go ahead.
No, how do we get it?
Yeah. You were gonna say, right?
No, well, I was gonna say, but I was waiting for somebody else to say, so I'll say it. So how we do it is we get the perimeter first, which is we take both sides times 2 and add them together. So that's 52.7 times 2. That should be 104 and 14 inches, which is 105 and 2 inches. And then we do 48 feet, 10 inches times 2. That should be 96 feet, 20 inches, which we all know is 97 foot 8 inches. Now we add those two together and divide by 12. And I'm just not going to do it right now. But as long as you know the process, and see, the thing of it is you don't have to guess at anything here. The numbers are all there. And the numbers are the numbers. You have every piece of information you need to solve the problem. This is not algebra. You're not trying to find some hidden numbers. They're all there. As long as you understand the process, you will get there with the numbers. And if you're using your calculator and your fingers are pressing in the right buttons, you will get the right answer every single time. No, like, but remember, you sometimes will not press the right buttons, which is why I always run a tape. When I have any kind of sums, especially long sums, I do them on a calculator that has a tape, so that when I'm done, especially with I'm handing you a bill for a whole, laundry list of materials that I've priced out, I'm going to add them up I'm going to add them up once with my calculator, and I'm going to check off my tape. And if my tape has every single number on it, and it has a plus if I'm adding them, and minuses where the minuses go, that's going to be the number. Whereas if I don't check myself, if I just press in the calculator, like a 10 or 12 column, which is, I do 20, 30 columns of numbers, I'm going to come up with a number, but I'm not going to be sure it's right. So I'll do it again. Figure if it comes with the same number twice, it's going to be right? Come up with another number. Let's do it again. Come up with that first number. Should I take the first number? No, maybe the second number was right. You know what I mean? So if it really counts, what I mean by counts is long numbers that you're presenting somebody a bill where you're adding up monies, run a tape. If it's long numbers, period, run a tape. Do yourself a favor. Check your math.
When you're making a cut list, do you account for the eighth of the saw blade when you're cutting down the board?
Well, not when you make a cut list. You might make it in your rough, thinking about your roughs, thinking about, okay, can I get 4 24-inch boards on an 8-footer? And you tell yourself, no, I can't. So it won't affect your cut list. Your cut list will say 4 at 24 inches, but your rough cut list, you'll take your finished cut list and decide what to get those numbers. If you put 1 8-footer for those 4 24s, you're not going to have enough. That's when you need to think of it, when you actually order the material. For instance, like the 15-foot forms that we did. I got 16s, figuring a foot was going to be enough. And I made it work, but I had some damaged ends. So the ends of boards oftentimes get checked, crack, get somehow damaged, or they're, a lot of times, more often than not, you will need to cut the end. You'll need to cut the end for square anyway. So you always want to have enough to be able to square up your ends and be able to deal with any BS You know, so don't order something 8'1" to get 4 24-inch pieces out of it, right? But by the same token, if you're cutting up sheet goods, you can get 4 24s underneath, because your sheet goods are going to be 97. That inch is just for that. So somebody took it into account for you. So, you know,
Rodney,
yes.
in the previous problem, what do pieces of wall angle refer to?
I was thinking when I first read it that that was referring to corners, like drywall corners. But you wouldn't install drywall corners around the perimeter of the room. So, but the only thing I can think of is it would be a corner up from wall to ceiling. And that's where you need the perimeter of the rooms.
To what end, though?
For drywall.
I see.
You need to tape, you need to have a corner where your wall meets your ceiling in drywall. Or
Got it.
Plaster as well. Plaster, you probably use mesh tape. And but you do a taped corner. I've never heard it called wall angle, but that may be the way they do stuff from back east. That's the only thing I can think of, Zach.
Got it. Thank you.
I can't see it on the floor. All right, so this foundation wall below will be used, okay, so it's going to answer the next two questions. So how many lineal feet of seal are needed to seal the foundation wall? Well, we just need to walk around the perimeter, right? Now, what we do need to find out is this run here. That wasn't, somebody said, project this. You guys all have books, right? Dylan's got a book. Austin doesn't have a book.
I'm enjoying the conversation.
I think we can leave one on.
It's already one on.
Is it? Okay.
Right.
I think we can see it. People at home can see it, but now what you guys, and actually you guys can see, but now Austin can see too. As soon as this reminder goes away, is that we are missing a measurement, aren't we? Come on. What measurement are we missing?
The little one.
Yeah, a little one, exactly. This one right there.
2 measurements, right?
2 little ones.
No, oh, you're right. We're missing 2 measurements. We don't have that measurement. We don't have that measurement, but those are available to us, right?
Could you infer that it would be 48
What do you mean infer?
from the top, or
It says
the
48.
total distance is 48?
Yeah.
So then those two maybe add up to?
Yeah, not maybe. It's a rectangle. We've been told it's a rectangle.
Right.
So which means the 2 long sides are exactly equal, and the 2 short sides are exactly equal, and it's parallel. So it's a rectangle with 90-degree corners. So we're going to believe it's a rectangle. So we know that the 36, it's 36 to there, and then what's left has got to be 36 from 48, right? So that's got to be 12. And then by the same token, this short run here that's not mentioned has to be 16 from 24. So that's 8. So we just go around again. We'll go clockwise, starting with the 36. 36 plus 24 is 60. Plus 48 is 108. Plus 16 is 124. Plus 12 is 136. Plus 8 is 144. And how many 14-foot sill plates are needed to plate it? 14 into 144. That would be 11, right? Because 14 times 10 is 140. So 14-foot plates, if you got 10 of them, you'd be 4 foot short. So get that extra one. You'll have a little bit left over. All right, a bedroom measures 14.6 by 16.9, has a walk-in closet measuring 8.4 by 8. Okay, we want to calculate the combined perimeter of the bedroom and the closet in feet and inches. So somebody describe to me how this is done. Somebody, anybody. What's the process by which that's done? And there's more than one. All right, well, let me tell you the 2 processes that I would use. One would be just to make the feet and inches into decimal feet. So that 14.6 would be 14.5 feet by 16.75 feet. The 8.4 would be 8.333, and the 8.8 would be 8.666, or 8.67, or 8.34. That's probably the better way to do it. Because that's 8.34 is rounded, actually should round down to 8.33. And the 2/3 is 8.66667 should round up to 8.7. That's probably the best way to do it, but you could turn those into decimal equivalents of feet and then just add all those up. Or we'll do 2 times the 8.4, 2 times the 8.8, 2 times the 14.6, 2 times the 69. Right? Or that's one way to do it. Turn it all into feet and decimal, into decimal feet. Or you could add up all the feet, right? You could do 2 times 14.28, put that over there. 2 times 16.32, put that over there. 2 times 8.16, 2 times 8.16. Add those up. And that'll give you your feet, whatever that turns out to be. And then add up your inches. 6 inches twice, that's 12. 9 inches twice is 18, that's 30. 4 inches twice is 8, that's 38. And 8 inches twice is 16, that's 54, which is 4'6". Add 4'6" to your feet. Got it? Follow me? I know that's fast, but as long as you understand the process, then you can go as slow as you want, because you're going to press in the right things, because you have all the information you need to solve that problem right there. All you need is a calculator and know how to tap, what to tap. Right? So there's more than one way to make that, to come up with that number. I've just told you 2 ways. And for my money, I would probably, the easiest thing I do, if I using a calculator, I'd probably just turn those things into decimal equivalents, because it's easy to turn them into decimals. And your calculator would like to do that easy. And you could do, if I was doing that on a calculator, I'd probably go 14.5 plus 14.5 plus 16.75 plus 16.75 plus 8.33 plus 8.33 plus 8.67 plus 8.67 equals 96.5 feet. I looked. Oh, that answer is actually in the book.
No, wouldn't be.
Oh, it's odd, not even odd. I got confused. But I have the answers. But you understand? You everybody get that? Yeah, I do that. Converting to decimals is a pretty good way to do it. But again, adding up the feet in one column, the inches in another, and then converting your inches into feet and inches, and then adding that. It's not a bad way to do it either. Fence post. Every 8 feet to enclose an area measuring 24 by 24. Interesting. So that's pretty simple, right? That's basically, it's a 24-foot square. So 4 times 24 is what? 96, right? Yeah. 4 times 24 is 96. So it's 96 feet around. 8 goes in 96 12 times. I guess that would do it. I would want to draw it just to make sure there wasn't one added or added at the corners. But if you were going to just use one at the corner, I think it works. You go 1, 2, 3, 4. I'd have to draw that. I'd have to draw it. I could draw it simply just right now, but I'm too tired to do it. So I'm not going to. There's crown molding, easy. Again, you got some numbers that aren't shown, but you have the information on there to get the numbers, right? That little short jog, to get that number, you need to take that 18'5" run and subtract this run over here at 14.3. The answer is 4'2". That's what that is. Same thing on this little short run. You just got to, oh wait, that's not true, is it? That's not true at all. I wonder why that seems so long. So that 14.3,
It's just that.
Well, you just take
Oh, I
that
see.
14.3
Yeah,
minus
yeah, yeah,
18
you
divided by
you don't really need it. You don't really need it. It's 18 and a half feet, right?
Yeah.
As long as you have the lineal foot. So basically it's the 14.3 from the 18.5, that number will be the sum total of both of those jogs. You don't really need to know the jogs at this point. You just need to know the lineal feet total. Right? We got that?
Yeah.
Okay, good. 22.6 by 9, 20'9" room needs to have carpet tack strips from the perimeter. How many tack strips? Okay, so 2 times 22.6, 2 times 29, added together, divide 4 foot into it. Again, another one. I would do these were I you, because then you'll really be prepped. You'll really have the answers. You'll be ready for the test. You'll understand the stuff that I'm hoping that you'll learn if you don't know it already. How we doing here? Okay, we'll go to the end of this chapter and then we'll call it. So just a couple pages. We'll pick up a fun one. It's all the same stuff, right? It's all the same stuff. So does anybody have any questions about how this stuff is arrived at or the process, or anything that we've gone over? No? All right. So read your books, read 17 and 18. We'll do 17 and 18 next week. We'll hang on a second before everybody goes home. We'll do 17 and 18 next week. So you would be really well prepared had you gone over the book while we're apart. And this next week, we'll do 17 because area measurement's fun. Starts getting some cool stuff, and then volume measurement gets into more cool stuff. We'll get into cubic yards and things like that. But the area stuff, we'll get into square feet, square yards, which is really used widely in what we do in taking off materials and estimating materials. And then we'll do the volume measurement, which will get into cubic stuff, cubic feet of things, which is basically used. Well, it's used for air handling too, but it's really more used for concrete things, like that, concrete, gravel, things like that. And then the very next week, we're going to get into board feet and right angles and percentages and stuff like that. We're moving right along. Anybody have any questions for me? Any questions at all? Okay, well, keep up the good work, you guys, and keep showing up. And Miguel, if you get a chance, call me, man. Call me. Matter of fact,
Yes, sir. I could call
are
you
you gonna be
tomorrow.
around? When I shut this thing down, can I call you in about 15 minutes?
I actually got to get the girls ready for bed, but
Oh,
yeah,
shoot, I'm sorry.
that's it. Yeah, that's fine.
So yeah, okay, I'll give you a call, and there's that number that one I've been texting you back and forth on. That's a good number.
Yes, sir. That's good.
Okay, bud, I'll call you. In the meantime, you guys have a great weekend. Take good care of yourselves. Be safe out there. I'll see you next Thursday. I'll see some of you at City College on Saturday.
Thank you, Rodney.
Ones that can make it.
Saturday.
Yeah, this Saturday. Thank you. See you, D'Angelo.
All right.
See you, John. Austin, drive safe out there. See you out there, Matthias. I hope Matthias was a big help.
Yeah.
Saturday.
Thanks again.
Saturday. What time?
9 o'clock.
All right.
9 o'clock on Saturday. I'll send out an email too.